everyone. This is Namrata Sherkhane. Welcome to the Data Platforms Virtual Summit 2022. I am a cloud solution architect from Microsoft. Today, I'm going to take you through a short, details about what are the different customer use cases with Azure AI services. So we'll just look at a couple of use cases, plus how our customers are utilizing our Azure AI services and enabling their business transformations at scale. So we are amazed when what Azure AI customers are making possible in their organization and how they are transforming their businesses across three key areas. The first one is like using the machine learning to build predictive models, optimizing their business process. Second one is actually by utilizing the advanced vision, speech, language, and decision enabling capabilities to build AI powered applications or agents to deliver personalized and engaging experiences. The final one is basically applying a variety of AI services at scale to uncover the insights from the vast variety of data which they are already having. So let's take a deep dive on what is Azure Machine Learning. It actually helps you for boosting your productivity and it doesn't really require what level of skill do you really have. So rapidly, it will help you to build and deploy machine learning models using tools that meet your needs regardless of the skill levels. Use the no-code designer to get started with machine learning or build in Jupyter notebooks for a code-first experience. Accelerate the model creation with the automated machine learning UI and access built-in feature engineering algorithm selection and high parameter sweeping to develop and high accuracy models. Operationalize at scale with the robust ML ops. Basically, ML ops is one of the basic requirements for any of the machine learning models nowadays, right? So ML ops or your DevOps for machine learning streamlines the machine learning life cycles from building a model to a deployment and also for management and monitoring purposes. Use the ML pipelines to build the repeatable workflows and use a rich model registry to track your assets. You can manage your production workflows at scale using the advanced alerts and automation capabilities what Azure Machine Learning gives you. It also helps you to profile, validate, deploy your models wherever from the cloud to the edge. The second point is that you could innovate on an open and interoperable platform. What does it really means is that you could take the advantage of the built-in support for popular open source tools and frameworks for the model training and inferencing. So you bring in any of the models which you are familiar with or the frameworks which you are familiar with, like PyTorch, TensorFlow, Scikit-learn, etc., and start using it and deploy your models. Choose the development tools which you are comfortable with. After you have built and trained your models, you could be able to actually start inferencing it and deploy it onto the edge devices. I'm excited to announce that we also have introduced a breadth of performance optimizations and broad operator coverage. Okay. Uh, the final one, which is really important now is like you want to actually build your AI solutions on a secure, trusted platform and also to build and responsible AI, which is, um, catering to all your requirements and doesn't have any bias. So Azure Machine Learning helps you also for the audit trail, quota, and cost management capabilities for advanced governance and control. Right? Now, today I want to talk about some machine learning scenarios which we are seeing with our customers. Um, so uh, the common scenarios are like majorly use the predictive maintenance, inventory management, fraud detection, demand forecasting, intelligent recommendations, sales forecasting. And now I'll go deeper into two of these use cases, that's predictive maintenance and the inventory management. So this is one of the most common scenarios, right? So in case of our Schneider Electrics, a global power management company, they need to help the company efficiently manage thousands of the oil and gas pumps, pinpointing remote equipment, okay, that needs repair. However, sometimes a fault occurs and damage is done before company can even track or respond. Schneider wanted to be able to build a predictive model so that they could find and fix a potential problem before they start. So before you even get started with the predictive maintenance side, at the most basic level, you have to be able to do a remote monitoring to connect to with the connected devices basically. To ingest the sensor data in the real time from the remote devices at the well site and process and store the data and then send the data to your applications or dashboards. So basically, see, right, the data comes from the IoT devices, streaming and to your dashboards, like, and the data is stored at the data lake asset. But now let's see how we can add the machine learning to the actual, to the complete scenario to do the predictive maintenance. All you need to do is add one more layer of processing component. So here the data kind of flows, right? Now let's add one more layer to this, which is your machine learning. Okay. Firstly, what we do is we have the historical data in your data lake storage, which can be pulled into your Azure machine learning and then can be used to build and train the models depending upon your business requirements. Like what are the different parameters do you want to really train your models on? Once you have built your model, you need to then be sure that they are working and they are also validated as per your requirements. So the next thing what you do is that you package it and deploy the model back onto the devices, allowing you to do the predictions at the edge itself. Okay, so you package and you deploy the model. Right now, just deploy it at the edge. Now the next part that would come is that, oh, right. So could you see this? Yeah. Now the model is deployed and it is also using the model for inferencing. Now over the time, you would also see the change in the input data. So you would also want to basically trigger an automated retraining of the data, which also could be done using the Azure machine learning. So this way, actually for Schneider, the predictive maintenance solution has enabled them to achieve a substantial saving on maintenance, optimize the production and profit, and increase the safety of their workers and the environment by taking proactive actions. Now, moving on to the next scenario, which we have that is on the inventory management. Now, the goal of inventory management is to get the right product in the right place at the right time. For example, a retail store would traditionally capture points of sale data, store the data, visualize their sales in the dashboard, right? This would be the typical architecture and try to ensure that the stores are stocked based on the historical data. However, machine learning has the ability to vastly improve the supply and demand to better reflect the customer needs, enabling the companies to have a more proactive rather than a reactive approach. Right? So let's see how we can incorporate the machine learning for proactive inventory management. The first step would be like as in predictive maintenance scenario, we just walked through. But you would actually start by ingesting the data to build the model, train the model, right? Then you would actually package the model and deploy the model. Then the batch inferencing, you would be enabling the batch inferencing as per your requirements, right? And then Lastly, you can monitor the ML models to ensure the high performance or if required, retrain them. Now, coming back, uh, uh, you know, to the different area wherein our Azure AI services are being used, is the AI apps and the agents, which are kind of widely used in a lot of industries. Um, So to build a breakthrough application, we actually offer comprehensive set of domain-specific services with cognitive services and a comprehensive bot building platform with the bot services. So we have around 5 million transactions a month which happen onto the cognitive services. So let's take a deeper look at are what do we really have in cognitive services and how you can utilize them for different use cases. Now, the core part of the AI is to create a technology that can help the machine mimic the unique ability to perceive the world around us. The cognitive services offers domain-specific APIs that can help your apps make decisions, understand speech, vision, and language, and integrate these capabilities into your apps for immersive user experiences. So with cognitive services, there are different offerings across speech, language, decision, vision, and your web search. Right? I'll not go deeper onto what all these services are, but how you can actually leverage the services. Right now, let me come to one of our customers who are leveraging these cognitive services to transform the customer experiences. One example is the Spotify example. So uh, let's look at it, but let me see if I have shared my audio. Just give me a second. I'll share my screen again, Lord.
So Spotify's mission has always been about helping millions of creators out there to be able to live off their work. Soundtrap is part of that mission. And now we're launching Soundtrap for Storytellers for collaborative podcast creation available directly in the browser.
Soundtrap for Storytellers is an easy-to-use platform if you want to record a podcast. And then we have a very simple publishing flow, so you can publish your episode straight to Spotify.
The problem is that there's very few podcast-specific tools out there. We heard that is so hard to do editing of podcasts or audio in general. So then we looked into that problem and say, wouldn't it be better if we can actually edit audio as it was a text document? So you just cut and paste and move things around, and then automatically cut and paste the audio for you. It's a completely new way of thinking about how you can actually work with spoken word, and that's a very unique feature.
We are using Azure Cognitive Services, or more specifically, the speech service. Integrating with that was very easy and straightforward. We needed to find a partner that could provide that in the highest quality possible. And of course, we also needed high accuracy for the variety of accents and vocabulary and age and environmental conditions.
Every time you have this lag between that you want to do something that actually gets done in the creative kind of process, that hinders creativity. With Soundtrap for Storytellers, what we wanted to create is something that is super simple to use, catering for everyone that had this creative flow in them. So let's democratize storytelling together.
Wow, so that's the story of Spotify. Ahead. Coming back to the conversational AI platform, which I was, referring, wherein you could how the different conversational applications could be created, like our bot services, basically. Okay, so customers can build their conversational applications in a variety of ways depending upon the requirements. Like starting with the button, we offer developers a comprehensive and a popular open source framework, like a free for bot development. So you bring up the bot service, you build your bot, and the language you would want to choose to develop the bot in, like choose
C Sharp, Python, etc. We have the largest community on GitHub, which could actually help you to, enable your developers to build these things, right? The next is that we are allowed to host your bot in Azure with Azure Bot Service, where you can easily connect your bot to the multiple channels, both the first party channels like Teams, Skype, or the third party channels like Facebook, Slack, Messenger, etc., with the click of a button. So note with the richness of the open source community, we have the connectors to the worlds of Alexas and Google Assistants on GitHub. Okay, and customers have used this connector to deploy to the productions. So additionally, we offer a lot of pre-built AI models with the cognitive services. So you can add a natural language processing, speech, and even get started quickly with the question and answer maker, which is a service that can take you take your existing content and create or an FAQ document and convert it into an Q&A bot. So basically your experience onto a couple of questions which are automatically being answered for your customers using a bot. Finally, we offer a lot of solution accelerators to help you bring together these different services. Okay, so we have a lot of ARM templates which help for deployment, faster deployment, basically, right, and accelerate your end-to-end solution. On the final note, the top layer which you see, the software as a service, right, um, is also one of it, which is especially with the Power Virtual Agents, and just note that this is a SaaS designer tool meant for BDM and content owner audiences. Okay. Moving ahead with our common AI apps and the agent scenarios. So today, I'll talk more about the robotics process automation and the intelligent customer support. But we have these scenarios like personalization, sentiment analysis, object detection, intelligent agents, which are being used across our different companies and industries, which you can see like the Airbus, right? Starbucks, Uber, etc. Okay. So now let's take a look at what is there in the robotics process automation. At an operational level, manual data entry is often very time consuming and it is actually error prone. So robotics process automation makes it possible to streamline these processes of extracting a lot of data from an unstructured or structured information, like from a lot of documents, and you want to put them into a structured way for further analysis, right? Now, manufacturing company would receive thousands of PDF reports in a wide range of formats. Using an RPA platform with Azure Cognitive Services, the company could automatically extract the fields, tables, text from highly specialized forms to automate the data entry. If the data is in the forms that cannot be processed with enough confidence, then the software would notify the human agents that can that needs the content validation for that matter, right? So as you saw before, I'll okay. So as you saw before, like, with the feedback loop support, business can achieve more accurate data extraction by labeling the forms. Okay, so this feedback loop, which you can see right in this diagram. So there is this data ingestion from the client reports. You have the Azure function, which kind of goes through the form recognizer. Form recognizer does kind of, it's a service which would extract the key value pairs. So you need to train the models if it's a custom model, or you have a lot of pre-built models also available onto it. If you have something like passports to be extracted or some bills to be extracted, right? So what happens is all these data could be, all these unstructured PDF files could be, fed to the form recognizer. You can then get the information in a structured format and store them, and then ultimately have your analytics dashboards to take the further, further actions basis that data. So the subject matter experts have now more time to focus on the value tasks and analyze the business with greater speed and accuracy and depth. by using these dashboards rather than doing a lot of data entry job. All right, now let's look at the intelligent customer support use case. So this is one of the most, one of the most scenarios wherein a lot of people who are a lot of customers for that matter who are having a direct supply for their customers, and they have BPOs, and they do a lot of customer supports over the phone calls or emails or over chat, right? So many organizations are actually looking to enhance their customer experiences whenever they are contacting their call centers. Okay, so how this experience could be enhanced and how they could actually be able to answer or support to their customers faster, right? The latest speech recognition models from the Azure services are making highly accurate transcriptions possible. So furthermore, with the customer speech, companies can tailor the speech recognition for industry and organization specific vocabularies. A support agent can then use this particular text analytics. Uh, can you see this? Right. The speech basically, um, the speech from the customers would be converted, correct? And then you would actually do a lot of text analytics on top of whatever speech is converted to text, correct? You could actually then, after analysis, do the sentiment analysis. You can have the key phrase extractions, you have the named entity recognitions, and then you would actually be able to find out what is the sentiments in the live conversation, take actions real time, and then the support agent can visualize the insights and communication, whatever communication patterns and the trends basically are there to take an action. We are using these capabilities internally as well within okay, to power the intelligent customer support for Microsoft. So we walk the talk. Right. So finally, I'd like to shift our focus to the knowledge mining. That is the third portion of, where you can definitely leverage the Azure AI. So what exactly is knowledge mining? Let's take a deeper look. Now, as part of our approach to AI, we invest in a lot of new categories and trends we see from the decades, right, of experience in the space. The first wave of AI involved very specific applications, training a single model over one data source for a single problem, right, but not quickly evolved. Now, let's look at how we are using it to go from basic search to a knowledge mining use case. First, we started for especially for the search, right? It was with the keywords, so which involves the most basic search in applications with structured questions and structured answers from a catalog. Now then we moved, I hope the animation is coming right. Then it advanced to the contextual search. With the contextual search, language specific models are applied so that the variant of the similar questions can lead to the same answer. Okay. And finally, then we actually advanced more. And the next evolution is actually in many kinds of domain specific models across multiple content types. It's about bringing multiple AI services together to generate the knowledge and understanding over the whole body of information, right? So this is actually knowledge mining. Right. So the cognitive search basically uncover the latent insights from all your content. And to show you that it is a fully managed service, it's built in AI capabilities. So you could actually use a lot of AI capabilities, the different APIs which we just spoke about, like the cognitive services, all are built into a cognitive search to have an intelligent search basically, and it is also customizable depending upon your requirements. Right, and 6 million documents kind of are getting processed per day, and you could be able to use a cognitive search for processing this high volume of data. Right. So welcome to the Azure Cognitive Search. Azure Cognitive Search is actually making it easy for enterprises to ingest, enrich, and explore their structured as well as unstructured information. Now, first, the knowledge mining solutions connect to where our data lives, right? You would actually ingest the data with all the new different types of connectors which are easily available now. We can actually ingest the data and store this data into our maybe Azure Data Lake, Cosmos DB, or any other database for that matter, or Azure storage, right? The blob storage. Now we use the inbuilt AI capabilities so that customers can discover the patterns and relationship in their content. So you have all this different data which is already available. It would do a discovery of the data, understand sentiments, extract the key phrases from all the documents which are passed and indexed, right? And all without any data science expertise, because it is already doing in the background. It already has those models inbuilt, right? With new integration, with translator services, like you could also search and extract from the content which is supported, for our different supported languages. So even if the documents are in different language, you would be able to search those documents. Right. So this is the enrich. Basically, you enrich the information, extract it, and then you can store the enriched metadata that you can actually create with the cognitive search and apply it to any variety of scenarios, such as Power BI visualization, customer knowledge graphs, build machine learning models on top of this to get, with the new label data and trigger actions basis what information you're extracting, right, onto your applications. Well, now let's look at what are the common knowledge mining scenarios. Okay, one of the very important scenario is auditing and compliance. Like, it is one of the key requirements for all of the enterprises nowadays. And also there are a lot of legal implications which really enforce the organizations to do auditing and compliance and look at their security architecture as well, right? Other one is the digital asset management, the technical content review, the process management, customer feedback analytics, right? And the catalog search, which we just spoke about, like the catalog search for different retailers, to do in quick searches onto their inventory, right? Today I'm going to actually go a little deeper onto two areas, that is the compliance management and the digital asset management. So let's look at the auditing and compliance. Now, with the new regulations, organizations are actually facing a lot of challenge on, being on top of the audits and compliance requirements. And knowledge mining can provide help organize looking, stay above the board and be able to easily, cater to these requirements. For most organizations, the legal department face the challenges of reviewing the thousands of pages of documentations, right? So developers can use this knowledge mining to help their legal departments quickly identify the entities of importance from the discovering documents and flag the important ideas across the assets. Now, first, companies can ingest the unstructured structured data, such as, if they have the meeting minutes or deeds or contracts, licensing agreements or affidavits, right? And then they can do the document cracking. Okay, so can you look at this? Yep. So then you do the document cracking, and it involves a lot of things in document cracking, the process of extracting the text, the images, having the metadata using the OCR, basically the optical character recognitions to check what is there onto the unstructured data if there are like the licensing documents, the PDF documents, etc. Right? Next, they would enrich the data with AI to extract the key value phrases, detect the language which it is written in. Now create the custom models. Also, you could create the custom models to identify certain legal terms and clauses basis the domain which you're working with, right? So depending upon that, you can also create your custom models and extract the information. finally, the customers, or the companies explore this newly structured data via the search to ultimately support more informed decisions. They can easily search complex documents from specific people, places, organization, legal clauses, contracts, etc. All right. So they could explore it using different web apps, and search the document. Now, coming to the another scenario which I told was, the digital asset management. It is actually gaining a lot of tractions, and even the amount of unstructured data, right? Created daily, most companies have more files than they would actually know what data do they really have. Okay, sometimes leaving unused, archives of data, they would also not know what amount of data is there and what they could do with that data, right? Leveraging the knowledge mining, okay, through the search index makes it easy for the customers and the employees to find what they are looking for faster. Basically, it would help them to get to that information faster as well as with accuracy. So for example, a publication could actually build a cognitive search into their website to help readers find what they're looking for faster. Now, first, they can ingest the data, which you can look like onto the slide, right? First, they can ingest the data sets such as the magazine images, right? And the articles from the archives, as well as the metadata from the web and the company's own data sources, which they would already have. Now, next, the publication can enrich this data with automated image captioning and object detection on with computer vision, detect and translate the text if required, and then extract the important words from important words or phrases, people, location, etc. from different documents. Now, next, the publication, once this is done, right, finally they could actually index and can be finally the search index can be integrated into the company's website. So basically the search index which you see, it can be integrated with their websites and enabling to discovery of the new information as well as uncovering the new relationship between the content and the ideas of different documents which they already have, right? And making it easier for their customers who are using their website to find what content they are really looking for. Well, now let's see. One of our customers are leveraging our speech capabilities to transform experiences. Now, one example, not just of speech, like there are different capabilities that they are using, and one of the examples is the Met. So let's have a look at it. I'll play the video.
The Met is not just a place that you visit, but it's really a great service to an audience all around the world.
The Met receives 7 million visitors through its doors annually. However, we're interested in reaching the 3.9 billion internet-connected people all around the globe. The Met's Open Access Collection seeks to make the collection the most accessible, discoverable, and useful on the internet.
There's a lot that goes into creating a work of art. There's information about the artist. What was the artist inspired by? Why was an object created? So all that information, all that data about an artwork really helps you to get a fuller picture about why it was made.
Our collection spans 5,000 years. We have art from every culture. So just the sheer size of our collection makes it difficult to work with. Subject keyword tags enable us to find connections and patterns across eras, across artistic movements.
Now we're doing work with AI, projects like using tags with cognitive search.
Now that we can leverage cognitive search, we'll be able to tag the whole collection at a much quicker pace.
It's been very exciting to see visually similar artworks and tag prediction.
Through AI, we can see things that we didn't have the possibility to see with our naked eye. There are patterns, there's information that are discoverable, connecting art from one piece to the other. We're really able to understand things that we couldn't possibly have dreamed of.
Well, so with this, I come to an end of the presentation, which I really wanted to share with you the different use cases, in the current industry, which they really require the AI services, and especially how Microsoft Azure AI services are enabling our customers onto these different, real use cases in industry. With that, thank you so much for listening to me. Thank you for your time. And I would like to end the presentation with this. Thanks a lot. See you soon.